Welcome to Technology Learning Space YouTube channel. In this video, we're going to start a new topic, VMware vSAN. VMware vSAN is a software-defined storage solution from VMware integrated with VMware vSphere. Together with the EXSI and VMware networking software solution, VMware NSS gives you a complete software-defined data center solution. When you look at the legacy architecture of storage, like a platform shared storage, you can see a big storage box, a dedicated hardware with multiple processors, RAID controllers and all shared to EXSI host as LAN through fiber channel or iSCSI protocol. We can say virtualization really forced to change this or to redesign the architecture of storage. What VMware vSAN do, it aggregate the local storage like a local disk or direct attached storage into a single shared storage pool and connect it to EXSI host in a vSAN cluster over Ethernet. By this way, vSAN eliminate the need of a shared storage dedicated box and also brings more flexibility in configuring and provisioning of virtual machines. The ultimate aim of virtualization is to pool resources and provide it in a user-friendly way to consumers. There are various virtualization solutions available for virtualizing desktop, application, storage, networking, firewall. VMware vSAN contributes to a software-defined data center solution by providing a storage service and a service level agreement automation by aggregating local storage devices attached to the host in a vSAN cluster and sharing it with multiple EXSI hosts. When you look at the legacy architecture, storage was something which we configured and deployed in the beginning of the project. And you think about a situation, you need to change something in the storage characteristic of LAN or volume being served to a virtual machine. Most of the situation you need to delete the LAN or volume and recreate it with the new characteristics required for virtual machines. With software-defined storage solution, it doesn't require to repurpose or recreate the volumes with the required characteristics because vSAN can be adapted to virtual machine workload changes over time. For example, a virtual machine availability requirement or I/O pattern change over time. In vSAN, it is simple, a matter of applying a new storage policy to the virtual machine, to that specific virtual machine with the new required features and characteristics, and this happen without any manual intervention. Look at the picture here. You can see EXSI host connected over Ether network and controlled by vCenter. Sometimes people have a confusion about vSAN. Is it something which you download as a software and deploy it in an appliance or in a vCenter? There are some confusions about that. No, vSAN is built to the hypervisor, or we can say it is a pre-installed with hypervisor and controlled by vCenter. So you can enable vSAN from vCenter if you have a proper license for that. And the Ethernet connectivity, it can be 1 gigabit or 10 gigabit, it based upon the storage devices that you are going to choose. Such things will be discussed in more detail when we talk about the architecture and design of vSAN. So we can define vSAN as a software defined storage solution which aggregate local disk of host, EXSI host into a single pool and shared to multiple EXSI hosts in a vSAN cluster over network.
Configuration of VMware vSAN is not a big deal, but understanding the technology is more important than anything. So for a better understanding, I would like to divide the explanations into 4 categories. In the first session, we will talk about storage controller, RAID controller, and hybrid or all-flash configuration and capacity and cache tier also. In another session, we will spend some time to talk about the host's requirement, licenses, and what are the minimum configurations that you need to start with a VMware vSAN. Then we will talk about network requirements, what are the different type of virtual switch and the configuration required for the virtual switches and also about the network resource sharing options. And then we will talk about VMware virtual machine objects and virtual machine storage policy. This is a very important section because here we define the virtual machine property like availability and performance by assigning parameters like failure to tolerate, RAID, and number of disk stripes and all. So let us start with the storage controller. The very important thing that need to keep in mind when you start with VMware vSAN, you don't need to configure any RAID level on the storage controller or RAID controller. And when you plan to buy servers for vSAN, you should make sure that the storage controllers must support pass-through, HBA or JBOD mode, because EXSI perform operations directly on the disk. So the disk should be available as it is to the EXSI servers. If your existing servers doesn't support pass-through, HBA or JBOD mode, then you can configure RAID 0, but you have to make sure you keep a 1:1 relationship, which means you need to create a RAID 0 for each single storage device. For example, if you have 5 hard disks, then you need to create 5 RAID 0 configurations. Because if you configure a RAID level, example RAID 1 or RAID 5, then it will be appearing as a single disk to VMware vSAN. So there is no advantage by doing that way. So all the hard disks that belongs to the server or the local attached hard disk, it should appear as it is to the vSAN. So vSAN will perform the operation, or EXSI will perform the operation directly on the disk. In VMware vSAN, you have two choices for storage devices, hybrid and all flash. Hybrid is a combination of different performing storage devices. All flash means complete flash disks. So whether it is a hybrid or all flash device combination, you need to reserve one as a cache device, there's a minimum, and one minimum capacity device also. And the capacity tier support from SATA to SAS, or you can go for flash also. In cache tier, you need minimum one cache device for each disk group. When you look at the picture, you can see one SSD is reserved for each disk group for performing cache tier. And if it is an all flash configuration, then write cache is only required. 100% of the flash capacity is used for write cache only, because it is a high performing disk, so read cache is not required. In a hybrid configuration, for both write and read, cache is available. Next is about VMware vSAN networking. At least 1 gigabit Ethernet dedicated for hybrid configuration. If it is an all flash configuration, then 10 gigabit Ethernet is supported and recommended. Nothing stops you from configuring a vSAN network on a standard switch. You can configure it on a standard switch and also on distributed switch. The difference is, in a distributed switch, you can enjoy network IO controller. For example, you have a 10 gigabit Ethernet card in your EXSI host, and you want to configure this Ethernet card for management, for protection, for vSAN. In this case, using network IO controller, you can reserve some share for vSAN, some share for protection, and some share for management. That is the advantage of using a distributed switch. One of the important things that you want to notice here is VMware removed the requirement for network infrastructure to support multicast from vSAN 6.6 onwards. So you don't need to configure a multicast for vSAN 6.6 or higher versions. A VM kernel port for vSAN communication must be created. For example, in a vMotion, we create a VM kernel port for vMotion. The same method, we need to create a VM kernel port for vSAN communication also. And vSAN support to use network teaming, so you can use LACP protocol for teaming your network interfaces. Next is about VMware vSAN hardware and licensing. You can see the hardware requirements. The minimum 3 host EXSI hosts are required, and 6 GB memory per host is minimum, but it is recommended to start at least with 32 GB of memory. So if you are in a learning environment or in a lab environment, you can start with a 6 GB memory, but it is highly recommended to start with a 32 GB when you're gonna production. And the third point is important because when exceeding 512 GB of host memory, it is required to install EXSI on magnetic disks. So this means that you can run actually EXSI on a USB flash device or a SD card until you reach a 512 GB memory for a single host. So by this way actually you can save some cost, because you don't need a high costly SAS disk or flash disk. You can just run EXSI on a SD card or a USB flash drive if you don't exceed 512 GB for a single host. And the disk controller should be certified, and you need at least one certified flash disk for caching and at least one certified magnetic drive or flash device per host for capacity. We already discussed in the previous slides. Look at the licensing options available in VMware vSAN. You can see standard, advanced, enterprises, and also standard for robo, remote office, branch office, advanced, and enterprises versions. So one thing I want to notice you is about virtual distributed switch is available from standard onwards. So when you plan for a vSAN, you don't need to configure a standard switch. You can go for a distributed switch as it is a free, or as it is available from the basic license onwards. The advantage of a distributed switch is, as discussed, you can configure network IO controller. So if you have multiple link, you can aggregate it and you can reserve in terms of shares for vSAN network, for protection and for management. Next is about VMware vSAN storage policy. We can call vSAN as a distributed RAID or a RAID over network, because the purpose of RAID is what? It's to withstand with the failures, right? So based upon the RAID configuration, the performance and the failure of tolerance varies, because if a RAID 1, it can tolerate for a single disk failure. If it is a RAID 6, then it can tolerate up to 2 disk failures. So in the same way, from an availability perspective, vSAN can withstand with failures of one or more EXSI hosts and continue to provide the complete functionality for all your virtual machines. The important point or the difference between legacy storage architecture is VM availability and performance is now defined on virtual machine basis through the use of storage policies, not to LUN or volumes attached to EXSI host. To be more accurate, we can say these policies are applied on virtual disk basis. So when we create a virtual machine, availability and performance characteristics are based on two parameters: failure to tolerate, you can see FTT, and failure tolerance method. It can be RAID 1 or RAID 5 or RAID 6. So in the picture, the first configuration is failure to tolerate is equal to 1 and failure tolerance method is equal to RAID 1. So in a RAID 1 configuration, it keep a mirror of the same data. So here we said the storage policy is applied on VMDK. So a mirror of VMDK will be available in a second EXSI host, and an additional witness will be generated in a third EXSI host. So you need minimum 3 EXSI hosts, and it will occupy 200 GB if VMDK is 100 GB. So it is 200% of the VMDK is the occupancy or the capacity required for RAID 1 in a vSAN. And the performance is higher compared to RAID 5 or 6, and the failure to tolerate is 1. It means if first EXSI is down, it will continue working, all the functionality will continue until the second one goes off. Look at the second scenario. Failure to tolerate is equal to 2, and failure tolerance method is same as RAID 1. So as I said, the RAID 1 means what? It will keep a mirror copy of the original data in a second disk. So here it is a distributed RAID. So VMDK have one copy at mirror EXSI 1 and a second copy at EXSI 2. But the FTT, the failure to tolerate, is equal to 2, right? So it means it need to withstand with 2 failures of EXSI host. To meet that, we need one more copy of VMDK. So for a configuration like failure to tolerate is equal to 2 and failure tolerance method RAID 1, in that case there will be 3 copy of VMDK in each host, and one witness is also generated in a 4th host. So the minimum number of host requirement is 4. Performance will be high, and failure to tolerate is equal to 2, and the capacity consumed is 300% of the total capacity of VMDK. Now look at the other two options, RAID 5 and RAID 6. In a RAID 5, the failure to tolerate is equal to 1. The VM functionality will continue for a single host failure. The performance will be less compared to RAID 1. Capacity usage is low because if you have 100 GB VMDK, then it will consume 133 GB only. The minimum number of host requirement is 4. When it comes to RAID 6, the consumption of capacity is a bit high, but it offer you failure to tolerate 2, and the minimum number of host requirement is performance is a bit low, capacity usage is also low, so you can save some space in your hard disk. During all this explanation, I talked about protection of VMDK only. But a virtual machine means it's a combination of different files like .vmx, swap, log, etc. So how these files are handled? Because if you just protect a VMDK file, and in case of a failure, you cannot bring back the virtual machine along with a VMDK. So let's see how these are going to happen. Let's see how this works. So a vSAN is a object-based storage, and following are the virtual machine storage objects. So when you create a virtual machine, it creates some files and disks in your data store. Here VM home namespace includes .vmx, .log, guest customization file, vSphere replication, SRM files, many files like that. So the point is, whatever the storage policy that you applied for a VMDK, for example, it is FTT is equal to 1. The same policy inherit to the VM namespace also. So VMDK is an object and VM home namespace is an object. So whatever you applied for a VMDK, the same will apply for your VM home namespace. So if you apply FTT is equal to 2, then the same FTT is equal to 2 will apply for VM home namespace object also. The second one is virtual machine swap. Its policy always has set to number of failures to tolerate is equal to 1. Because the swap does not need to persist when a virtual machine is restarted, right? Because if HA restart the virtual machine, for example, on another host or in a cluster, a new swap object is created. Therefore, there is no need of an additional protection for virtual machine swap. Next objects are VMDK and deltas. VMDK and snapshot files like delta files are the only object that obey all the capabilities that are set to VM storage policy. Then the final one, witness component is get created once you create a RAID 1, and these components make up like a leaf of a RAID 1 tree. It contain only metadata. They are there to be like a tiebreakers and are used for quorum determination in the event of failures in vSAN cluster. When we talk about VM storage policy, we talk about only the number of failures to tolerate and failure tolerance method only. There are some other rules that you can set and apply for a virtual machine. You can say additional to number of failures to tolerate and failure tolerance method. The third one, number of disk stripes per object. In general, default stripe width is 1 and that should meet most of your requirement. From a write perspective, increased stripe width may or may not improve performance, because you know why? When you write something, that is going to be written on the cache. So increasing the stripe width is not going to benefit unless it is going to sit on the second or third EXSI host. And there is no control for administrator. You can just select the stripe width. You cannot move the stripes into different EXSI host. But from the read perspective, for example, you have a virtual machine which have more activities, read activities, then increased stripe width will help you to improve the performance. The important thing to note here is it is recommended to change only if the read cache misses are identified as a performance constraint. So it is only recommended if you have such a situation. The fourth one is IOPS limit for object. So this is to ensure that VMDK does not generate more than a predefined number of IO operations per second. So this rule will help you to get rid of the noise from neighbor VMs. The fifth one is flash read cache reservations. As you know, every disk group have one flash disk or cache disk, and this is applicable only for hybrid configuration. You can reserve a portion of read cache for storage object VMDK. Sixth one, object space reservation defines actually the percentage of reservation for VM storage during the initialization. The final one is a force provisioning. If the force provisioning parameter is set to a non-zero value, then the virtual machine will be provisioned even if the requirements specified in the storage policy cannot be satisfied. So these are all the topics that you need to know before you start configuring a virtual SAN. So I would like to wrap up this video. In this video, we covered most of the theoretical part that comes in vSAN, and I hope you all got a clear idea about how vSAN working and the concept of vSAN. In the next video, we will continue with a demonstration on how to configure vSAN in a lab environment or in a real environment. And after that, I would like to do some videos on how to use the VMware free hands-on lab also. So that also will add an advantage for those who don't have a real-time or a lab environment in their premises. And at the end, I will do one more video on how to design vSAN and what are the monitoring and management day-to-day activities that you need to do on a vSAN. So that's all. Thanks for watching this video. Subscribe my YouTube channel for more videos.